Okay, so now I'm going to introduce a few new cool MongoDB features. So this lecture is just going to mostly be just a big, I guess like an info dump, a bunch of features. So I don't expect you to memorize all these features, but just this to get you a taste of what is possible when using MongoDB and Mongoose. So let's look a bit more at the schemas. So we defined this story schema last week. It has three things, pretty simple, three strings. An ID, a name, and some content, right? Mongoose lets you add more things to the schemas to make it even more restrictive. So let's say I want any stories to be no longer than 280 letters long. You can add this to the schema. So that means if somebody tries to post something ridiculous that's way too long, it'll just totally refuse when you try to do it. It's going to say, you cannot post a BB script into Catbook. This is too long. Don't do it. Someone's going to do it right now. I shouldn't have shown this slide. Yeah, so basically you try to, when you call the .save, it's going to throw an error, and Mongoose is going to crash and say, you can't do this. This breaks the schema. There are some other fancy options that you can add to the schemas if you look at the Mongo documentation. Like lowercase equals true. So that means whenever you enter a document that has weird capitalization, it'll just automatically force everything to lowercase. Yeah.
So if the user tried to post more than 280 characters, would the client side crash?
Well, it would. So when you send like post API/comments, right now it would probably show an error 500. Like this, it would say the server crashed when trying to handle this request. So that's kind of not what you want to do. You probably should have another check in the front end that says, if it's greater than 3, don't even send it to the backend at all. But this is kind of like a second line of defense to make sure that nobody can get around this. Yeah.
So it'll throw an error. It won't just truncate it.
Yeah, it won't truncate it. It'll actually refuse to do anything. And the error will like 500, unless you have something to handle this request. Unless you have some like try catch, like a dot catch on it. Like if you had a dot catch on .save, then you'd be fine. Yeah. Other things like lowercase, pretty self-explanatory. It takes any content and makes it lowercase when it makes it. You can look up all these fancy little add-ons you can add to your schema on the Mongoose documentation. It's pretty cool. Probably more useful is more complicated queries when you're looking for things in the database. So one thing that you might want to do is sort data. So let's say I add this one line to our query that finds all the stories. I'm going to sort by creator name. What the 1 is doing is that just determines like, so if it's 1, it's going to sort from A to Z. If it's -1, it will sort from Z to A. That's what that means. So now Catbook is going to be in alphabetical order. Right, that's pretty cool. You can also do stuff like limit the number of posts you have. So I do .limit 2, it'll only show 2 posts in Catbook. This would probably be useful because if you have thousands of Catbook posts, you probably don't want to show all thousands of posts at the same time. You might want to limit it to some like same number, like only show the first 64 posts or something. We probably should have done that because, as you notice, when everyone is posting spamming stories to Catbook, it starts to get really, really slow. So a dot limit would be a good use case for dot limit. One question I received is, what is the normal sorting order? So what if I just say story.find and I don't have any kind of dot sort after it, what order is it going to be in? So the short answer is that this is chronological order, usually. So in Catbook we're doing this, and it's basically chronological order. But not necessarily. So if you look at the Mongo documentation, it says that you should not rely on any particular structure. It's very vague about it. It's like it's usually chronological, but Mongo says that, we could change this order at any time. You shouldn't really rely on it. The reason for this is, for example, let's say you have a bunch of posts. They're all stored on your hard drive. Then, you delete some posts. Then, natural order is basically the order that posts are stored on your hard drive. So if I have, post 1, post 2, post 3, they're getting stored in order, right? So it's fine. But say I delete post 2. Everything's still in order. So now I add post 5. Is it going to go here? No, it's going to actually go here. It's going to try to save space and use the old space. So I'm not even sure if it'll do this, because Mongo says like, it's an internal feature, like they're not gonna actually explain how it works, but I'm assuming it's gonna be something like this. So if you're doing modifications, you need to update documents, delete documents, Mongo might shift things around in order to have more optimized behavior, not to waste space. So it's possible to end up with something that's not in chronological order. Again, I'm not guaranteeing you this is going to happen, because Mongo itself says it's not predictable. They might do fancy optimizations that shifts around the order even more. We don't know. A slightly better way to do this is by timestamping your documents. So in Chatbook, what we've done is we've added this timestamp field. So basically what this does is it has this default thing on it. So default date to not now. So what this means is when you insert a new message into the database, by default, it's going to generate a timestamp instead of to date.now. So these will automatically get added. It'll show you the current date and the current time, accurate to like 1 millisecond. And then you can just sort on timestamp if you want to do that. So this is a little more reliable way of sorting by timestamp. And then you can do timestamp -1, and then everything would become in reverse order. Now this is still not perfect. Like for example, what if you had 2 servers posted to the database, and those 2 servers had slightly desynchronized system clocks? But whatever, it's probably it should be good enough. Yeah. Back to queries, though. So this is something we're familiar with. You can find something where x equals y. So I want to find all users where they're 18 years old. Pretty self-explanatory. What if I want to find all the users that are under 18? You can use this funky syntax here. That's one way to do it. So LT, so anything that starts with a $ in Mongo is called an operator, which is just fancy, just something that has a special meaning to Mongo. So LT is not just a normal variable name. It has a special meaning. This meaning is less than, so LT for less than, and GT for greater than. So you can find age where it is less than 18, or age where it is greater than 50. Mongoose might have some fancier features like a dots greater, I don't know, but like this is the vanilla, like normal Mongo DB way here. What if I want to do an OR? So what if I want to find all users that are either under 18 or they're over 50? This is kind of a weird thing to look for, but like, say I wanted to find only young users and only old users. There's the OR operator, which will let you put in a list of criteria. And if any of these things is true, then it'll return that user. So this query right here will return all users that are less than 18 or greater than 50. And let's say I want to do fancier. I want to find all users that are less than 18 or greater than 50, but not Buka Buka. I don't care about Buka Buka. He's dead to me now. You can use this NE function, which means not equal. So I want to find, so there's 2 criteria here. The first one is the top one. Either they're under 18 or greater than 50. And the second one is name not equal Buka Buka. You'll notice that I never explicitly wrote $ in the end. That is a thing, but you usually don't need it. Because when you have a list of criteria, they're ended by default. Like it assumes that if I say age 16, name me man, it's going to assume that I'm looking for somebody that is 16 and the name is me man. So the point is, and is implicit. But if you want to do or, then you have to explicitly say $or. Great. So next is dealing with arrays. We haven't really done this much, but you can have something like an array. So here's a simplified version that is similar to the team schema that we're using on the submission portal. So for every team, we have to store stuff like a team name, their GitHub URL, whether they're competing or not, and a list of their members. Suppose that this field is just an array of GitHub usernames. Now let's say I want to find any teams that have me on it. So I find teams where members is core 2067. Now this is interesting because this doesn't mean found members where members equals core 2067, because members is an array. This actually means to Mongo, it'll interpret this as meaning any members that contains me. right? So if the key is an array, it by default looks for like contained, not like exactly equality. If that makes sense. What if I want to find any teams that have multiple things? If I want to find teams that must contain me and it must contain Aaron, I can do something like this. So any teams where the members has all of these things. You give a list, right? Or there's another operator called size. I can find all teams with 2 members by saying where members has size 2. Like you should be able to read these kind of left to right, like members size 2, members all these 2 guys, right? So that's how this works. There's a whole big list of query operators that you can look from the Mongo documentation for. And so it lets you do complex things like this. Do I have time for this? I have time for this. So there is another type that we didn't really use in the Kappa lecture, but there is a schema type called object ID. So in Kappa, when we did this, we made this type a string. Creator ID is a string. But it's a little more specific than this. It's not any old string. It's an ID, it's an underscore ID. And Mongo has a specific type called object ID, which is used to represent specifically underscore IDs. So this is a little more specific. So for example, in our current schema, we could say creator ID equals test ID, and it would be fine because it's a string. But if you do this, if you try to make a new story where the creator ID is equal to test ID, it's going to be like, it's going to reject it. It's going to say, what are you doing? Test ID is a fake object ID. It's not real. So it will fail to pass the schema. So this makes the schema a little more strict, and it makes you specifically looking for object IDs. And there's something, and yeah. So I'm going to talk about the application of object IDs and why they can be useful. So here's our Tapbook schema. So we've got our 2 things. We've got our story schema. It has a creator, and it has some content. And we've got our user schema. It's got your name and Google ID. This is kind of meh because like it has the same data in 2 different places. Like your name is stored under your user schema, and it's also stored in every single post. Like what if I was on Kappa and I wanted to change my name? How would I do that? I would need to change first my name stored in a user document, and then I would need to manually go through every single story document and start changing the creator name to my new name. That would be a pain. So whenever you have the same data duplicated in multiple parts of your database, it can make it kind of a pain to manage. So preferably, let's say I did this instead. So let's say I just get rid of the creator name, and all I'm going to do is store the ID of the creator. I can do something like this. So first, so in practicing using the async await syntax, first I'm going to find one story. And it's going to return to me these 2 things. How do I find the user's name? All I have is their ID. I'm going to send a second query. I want to find the one user whose ID is equal to this object ID. And then put them together. And it'll look like this. Right? So content is equal to hello, and then the creator is going to be equal to this user object I just found. Right? Where's the office? Yeah. So this is using syntax you should be familiar with already. Just 2 basic Mongo queries. But there is a better way to do this, and it's called populate feature. So, first thing you can do is you can make the schema a little more specific here. So creator is not going to be any object ID. It's going to specifically be talking about users. So that's what this ref field means. It means that a creator refers to a user model. So inside the quotation marks, you put the name of the model that this field corresponds to. And look at this magic I'm going to do right here. So I'm going to find story and say dot populate creator. So what does this do? What this does is it looks for the creator field in your schema. And keeping in mind that it refers to a user, populate is going to replace it with the actual user object. So it's going to do this, right? It's going to take the user ID and replace it with the actual user document. So that act is called populating. It's when you take just this object ID and you substitute it for the actual user document itself. Right? So it's the exact same thing as doing this, except populate will just automatically combine for you like this. So, and this is beneficial for performance reasons, also because in the previous approach, you had to send out 2 separate requests to the database. But here you only have to do 1. And as we should be familiar with right now, sending out requests over the network is slow, and you want to minimize them whenever possible. So if you can reduce 2 operations into 1, it's generally better to do so. So here's one way you could do this, right? And replace our captive models with something like this. Yes. So, yeah. Let's take a look at some example queries. I'm going to shamelessly plug. I'm going to be using a tool that I made to help browse Mongo queries. So, let's see. I actually did get the SRV address. Copy and paste this SRV. And then we'll take a look at the data and run some queries on it, just to practice what we're doing. Okay, so here is the captain database. It's popping. We got all the stories here. They got all these guys. I'm going to run a query. So let's say that I'm going to find all queries. So something simple. So creator name is me. Cool, that works fine. What if I want to do, let's practice using the or syntax. So what if I want to find all stories, all comments that were posted either by me or like by Noah. So you can just like this. So or creator name is me, or creator name is Noah. Cool. There you go. So there's things by me. No post me? Yes, of course if you want. Get out here on. Okay. Cool, that's how that works. What other things can I use? What other features did I talk about? Greater than, there's greater than. So for example, if anybody did the cat happiness homework, I don't think anybody did, but if you did do the homework, some users have a cat happiness field on it. So what if I wanted to find all users where the cat happiness is greater than 5 or something? Cat happiness is greater than 5. Cool, and that works fine. So you should be able to put these in any mongoose .find query. You should be able to write a string like this, and it'll find for you, right? So yeah, you can use these in your projects. And I presented a lot of features. You might not remember all of them, because there's a lot. So basically, the takeaway from this is, there's a lot of things you can do with Mongo, so just look them up. The documentation is very useful. I have a link here for the MongoDB docs, which should give you docs for like the operators like $sign or $sign greater than $, that's it. And the Mongoose docs, which should give you documentation for things like populate, things like schema types. Yeah, that's basically it. Is there any other questions about Mongo or Mongo features?
What was that tool you were using one more time?
It's called Mongo-Ranger.
You made Mongo Ranger.
I made this when I was interning at MongoDB last year. Yeah, I made it for an hackathon. It was like a side project. Yeah, MongoDB is web scale. Okay. That is about my.
Thank you, Corey. Thank you, Corey.